Let's go ahead and do the last section for chapter 2. And one of the things I want to let you know is this is just a brief introduction of correlations and regressions and how it relates to scatter plots. So we're going to focus mostly on the plots. We'll go into this in more depth in chapter 10, where you will talk about and you will practice doing the calculations involved. So this is FYI. Don't get too caught up in how we got these numbers. Just look at the scatter plots and the numbers. The first thing we're going to talk about is vocabulary again, and correlation is when one variables are associated with values of the other variables. So for instance, your shoe size might be related to your weight. So as your shoe size goes up, your weight goes up. Or a correlation is on a late model car. The older your car is, the less it's worth. So as the age goes up, the worth goes down. If you're talking about collectibles, sometimes as the age goes up, the value goes up. So that would be a correlation. That would be a linear correlation that are approximately straight line. Now there are other correlations. So there's curvilinear correlations. Miles per gallon is one of those. As your velocity increases, there's a point where your miles per gallon increases, but that ends at a certain point, and as you start going faster, your miles per gallon starts going down. That would be a curved relationship. We're only going to be talking about linear relationship. But one thing I want to point out is that correlation does not imply causality. And we'll talk more about that in chapter 10. I just wanted to mention it here. What we do when we do scatter plots, we are plotting ordered pairs, x, y. The horizontal axis is used for the first variable, which is the independent variable, and x, and the vertical axis is used for the y variable or the dependent variable. And again, this is just for your information right now. So here's an example of waist circumference as it is related to arm circumference. And you can see there's a general uphill pattern here. And so we can say it seems as if they're associated. Those with a larger waist circumference tend to have larger arm circumferences. Now here is weight as related to a pulse rate. You can see it's just a big glob. So there's no linear correlation here. But let's just look at this individual right here. So they have a weight of about, almost 150 kilograms, and their heart rate is about 70 beats per minute, a little bit more. The person represented here is about 75 kilograms, and their heart rate is between 100 and 110 beats per minute. So that's how we get those points on our scatter plot. What we do is we use a correlation coefficient, and it's called R, and there is a way that we calculate it. Again, we will use StatCrunch to calculate that for us. But what I wanted to let you know is that right now we're going to talk about what R means. We're not going to talk about how to calculate it. So R is always between a +1 and a -1. So positive 1 means as x goes up by 1 unit, y goes up by 1 unit. A negative 1 correlation means as x goes down by 1 unit, y goes up by 1 unit, or vice versa. So if r is close to a positive or negative 1, there appears to be a correlation. When r is close to 0, there would not be a linear correlation. I'm going to back up here. If we look at this graph, if we use this data to calculate r would be very small, very close to 0, because there doesn't seem to be much of an association here. So here we have the shoe print length versus the height, and we have the data on 4 individuals here, and you can see that we've graphed them here. There was kind of an association, but not really. It wasn't very exact. I could kind of draw a line in here, but where do I go? Up here, down here? It gets weak out here with these last 2 individuals. When we calculated the correlation coefficient, it comes out to be about 0.6, which is kind of in the middle, meaning it's kind of wishy-washy. And then what we do is we go to the p-value, and the p-value is simply a probability, and we will talk much more about p-value in the second unit. If you have a p-value that's close to 1, and this is a probability, so remember the probability of 1 means it will happen, the probability of 0 means it won't happen, but as that probability goes up, the strength of the relationship goes down. So what this tells us is that we have a probability of getting that correlation coefficient of 0.591. Think about this as a percent, 29% of the time. Well, think about it. If you're going to be playing darts and you can hit the bullseye almost 30% of the time, it isn't going to take as much skill. It isn't going to happen as rarely. So there's not much evidence to support that there's a linear correlation between the shoe print length and the heights of individuals. When we have a small p-value, and we usually set that up and we talk about 5% or 0.05, that means it would only happen 5 times out of 100, and that's a pretty small occurrence for something to happen by chance. Here we have a bigger set of data, and this time the correlation coefficient as 0.813 and the p-value as 0. So we would get an R this extreme almost never if the relationship weren't true. So this, with more data, gives us a stronger linear relationship. So again, this p-value is very small. That gives us a lot of evidence that we have pretty good value here for our R. Now, when we talk about correlation, that's simply the relationship. When we talk about regression, what we're doing is we want to come up with the line that fits that data best. And this is the line of least squares regression, and you might recognize it in a little bit different form as y equals mx plus b. We can use that shoe print data and our line of least squares regression, and we can get a line that models that linear relationship. Now later in chapter 10 we'll see that we could use this line to help predict the height of someone from their shoe print length, And if this data is true and valid, that might be good if I'm a police detective and I find a shoe print in the garden outside the window. I might be able to see how tall the perpetrator of the murder in the library would be. And then this just gives us that information we would get from, this is from StatDisk. We will be using StatCrunch, but we get the similar kind of numbers from that. And this is the line of least squares regression. So if we have a shoe print length, we can predict what the height would be. So this is the end of section 2.4. What's going to follow are those active learning questions for chapter 2. I'm going to leave it on each slide for 5 seconds and then go on to the answer. Use these if you wish. If you've printed out the slides, they're there too for you to quiz yourself.